Sorry, I kind of ran out of room there. Suppose R of x equals 6 square roots of x, and that's revenue. And cost is 3x squared. Is there a production level that maximizes profit? Profit is just your revenue subtracted by your expenses. So revenue subtracted by cost. So the revenue is 6 square roots of x, and the cost is 3x squared. And they're asking us, is there a production level that maximizes profit? So if this is your profit, then take a derivative with respect to x, and set it equal to 0. And that's a negative 1/2, so I'm going to put that on bottom. And 6 divided by 2 is just 3. So there's our derivative. We set it equal to 0. You maximize or minimize things by setting the derivative equal to 0 and then solving or checking where the derivative fails to exist. And we have a divide by 0 at x equals 0, so that's a potential maximum or minimum. So we'll want to investigate that when we're done. So to solve for x, we want to multiply both sides by the square root of x. So the square root of x times 0 makes 0. Square root of x times 3 over the square root of x makes 3. And then square root of x times 6, that makes 6x to the 3/2 power, because a power of 1 plus a power of 1/2 makes 3/2. And then if you want to solve this equation, subtract that 3 from both sides. Divide negative 6 from both sides. And then we got to use 2/3 power to both sides, okay? So we got x is 1/2 to the 2/3 power, so 0.5 to the 0.666666666 repeating power. So 0.63 roughly I got. Okay, so I found two critical points. At x equals 0, we have a critical point. At x equals 0.63 repeating, we have another critical point. So with all critical points, you should be testing them to see whether they are maxes or mins. So here's our number line. Here's x equals 0, and here's x equals 0.63. So we want to test the number to the left and to the right of these to see whether they're max or mins. Actually, we need to plug in the numbers first. If I plug in 0 into our profit function, I get 0 for profit. That's our break-even point, because you don't make anything, it doesn't cost you to do anything. So I can't do -1 units. It's not even worth testing this side, right? I can do something between these two critical points. I can plug in 0.5 in for my profit function. So if I do that, 0.5, the square root times 6, and then we got 0.5 squared times 3, so 0.75. We want to subtract 0.75 from it, so it's 3.49. Okay, so that tells us we're going to hit a maximum here, right? Because since it's a continuous function, we expect this to keep increasing until we hit a critical point. And I'll show you that it's a maximum for sure in just a second. Let's plug in a number to the right of this. If you plug in 1, that's 6 minus 3 makes 3. So if you plug in 0.63, our other critical point, 0.63, we take a square root of it times 6. And then we got 0.6, what is it? 0.63 squared times 3. So we got 1.19. So that's 3.57. So 3.57. Okay. So at 0.63, we've hit a maximum. 3.57 thousand or something is our profit. Okay, so they should, since this is thousands of units, that means they want 630 units. That'll maximize it.